Okay, in this video we're going to go over some links between the periodic table and ions. So the periodic table gives us tons of information, and this is just a little piece of that. This information is going to help us when we get to things such as ionic bonding and naming, so that we're able to use those relationships with our periodic table. So first, let's look at some things that we need to make sure we remember. The first one is those main or representative groups. So we're talking about group 1, 2, and 13 through 18. So we've skipped over that transition metal section. And this is where our valence electrons, remember E with the little negative means electrons, are usually located. In chemistry, we'll talk about these being the S and the P blocks, but the same idea still stands. Now, let's talk about valence electrons here. So we just said that these groups are where most valence electrons are usually going to be located, so we want to make sure we know what those valence electrons are. So valence electrons are electrons in the outermost energy. And these are gained, lost, or shared to form bonds. So valence electrons are electrons in the outermost energy level that are gained, lost, or shared to form bonds. Now let's talk about how elements often decide how many electrons to get rid of or to take in. And that's what we call the octet rule. So oct means 8. And it's a prefix. It's kind of a universal thing that you may have heard before, like an octopus. So oct means 8. The octet rule says that most elements want 8 valence electrons. That's their goal. They want 8 valence electrons. There are 2 main exceptions here: hydrogen and helium. If you go into chemistry, we'll talk about expanded octets and other exceptions, but for right now, the only 2 that I really want you to know are exceptions are hydrogen and helium. And that's because they're right here in this first energy level, and there's only 2 places for electrons to go. So they're only looking for 2 valence electrons in their outermost energy level. Now let's remind ourselves about an ion. So when I'm talking about an ion, I'm just talking about a charged particle. I'm going to have a plus or a minus there. It's something that is not neutral. There's 2 specific things here. Think back to our atomic structure. Our cation is a positive ion due to the loss of electrons. So positive ion due to the loss of electrons. That's where that atom is going to have more protons than it does electrons. The other form of that is an anion. So this is a negative ion due to the gain of electrons. And again, remember that E with the little negative means electrons. So we are going to bring all of this together that we've previously learned. We're going to add 2 more little things, and then we are going to complete this table to kind of give us an overview of how all of that works together. So one of the new things that you're going to see is what's called a dot diagram. When you get to chemistry, we'll talk about Lewis structures, and this kind of lends itself into those Lewis structures. But a dot diagram is a model. It's going to give us some visual information, and it represents valence electrons around an atom or an element, whichever one you want to write there, using dots. So I'm focusing on my valence electrons, how many I have, what element it is, and representing that by dots. We're going to do a whole row of examples right here, so I'm going to hold off on examples, but you'll see how we're going to connect these valence electrons to these dots. When we get to ionic bonding, I'll also show you a little bit of how we're going to use those dots to help us see how bonding is happening. Okay. And then the next thing we have is standard ion formation. So by using the patterns on our periodic table, we can learn a lot of things. Okay. This is just one of the many pieces of information it gives us. PT's periodic table. So by using the patterns found on the periodic table, several groups will always produce, I'm going to say well usually, there are some exceptions, we won't talk about them in here, but there are some. Several groups will usually form the same ion. So for standard ion formation, by using the patterns found on the periodic table, which we're going to walk through right down here, several groups will usually form certain ions. So we can look at the periodic table and say calcium forms a +2 ion. We're going to look at how we can do that. These are often called standard ion formations. You may hear them called oxidation numbers. Okay? We're just looking at that production of a charge, which is going to affect its reactivity. So let's go ahead and look at our table down here. So the first thing that it wants to know is our groups. Now, we're focusing on our main or representative groups. So when we fill these in, we are going to skip those transition metals. So let's go ahead and fill this first part in. Move that a little bit. There we go. So I'm going to do group 1, 2, 13, 14, 15, 16, 17, and 18. Now we're going to talk about valence electrons. And we said that our valence electrons were those electrons in our outermost energy level. Okay. When I'm looking at my periodic table, I'm going to look at a single period. So let's say I'm going to look at period 2. However many boxes I'm touching in group 1, 2, and 13 through 18 gives me an idea of how many valence electrons I have. So if I'm in group 1, I'm just going to lithium. I'm touching one box. There's one place for an electron to be from that element. So it's going to have a valence of 1. In chemistry, we'll talk about orbital notation and electron configuration, and that's actually going to give you a clearer view of what that looks like as far as how it's going to bond, where the electrons are. But for right now, we're just focused on group 1 has one valence electron. Group 2, 1, 2, has 2 valence electrons. Now we skip our transition metals, so 1, 2, 3. So group 13 has 3 valence electrons. Group 14, 1, 2, skip transition metals, 3, 4. You seeing a pattern here? 1, 2, 3, 4, 5, and 6, 7, 8. 1 and 2, it's the exact same as the number. 13 through 18, you just need to drop that 1. Okay. Again, we're skipping those transition metals because valence electrons were focused on those main and representative groups. Now, let's say I wanted to draw dot diagrams of these. So I said period 3. So period 3 is right here where sodium starts. Put that up. So when I'm drawing a dot diagram, first thing I need to do is write my element symbol. So if I'm looking at period 3, group 1, so group 1, period 3, that's sodium. We already decided that it had one valence electron, so I only need to put one dot. Now I'm going to look at group 2, period 3. So group 2, period 3. Be careful because I need to look at my numbers, not just the third element down. So group 2, period 3, reading it like a graph, I have magnesium. And they have 2 valence electrons. Put 2 dots. Now I could have done up and down. Most of the time, electrons want as much space as they can have to themselves. For right now, I'm not worried about where you're drawing these dots per se, but as we move on, that may become more important. Now, looking at group 13, period 3, 13, period 3, got aluminum. We said that it had 3 valence electrons, so I'm going to put 3 dots around it. Perfect. Group 14, period 3, group 14, period 3, silicon. So I'm going to put Si. We had 4. 1, 2, 3, 4. Group 15, period 3, phosphorus. And you'll notice on this one, we kind of look at this as if it's in a box. It has 4 sides that I can put dots on. So when I get to phosphorus, I'm going to have to double up on one of those sides. And that's fine, and we'll talk a lot more about that if you take chemistry as far as why we do that. Okay. Group 16, period 3. So group 16, period 3, sulfur. It had 6, so we're going to put 6 dots. 6. Okay. Group 17, period 3. Group 17, period 3, we got chlorine. 7 valence electrons, so 1, 2, 3, 4, 5, 6, 7. And the last one for our dot diagrams, group 18, period 3. Group 18, period 3, and we have argon. And it has all 8. Now this is a full octet. You notice all these others, they still have some space where I could put a dot. Argon doesn't. It's full. That is why we say sometimes it's satisfied. If you've had a really good meal, you were satisfied with your food. Okay, so argon doesn't want to lose any because it has 8, and it doesn't want to gain any because it has 8. So that's part of why we call those group 18 elements noble gases. If you think about nobility in history, they don't like to mess up their bloodline. They're not trying to interact with anybody because they don't want this to be messed up. So group 18, non-reactive, we call that inert. So keep that in mind. Now let's talk about charge. So when I'm looking at charge, I either want to kick electrons out to look like a noble gas, or I want to take electrons in to look like a noble gas. So those are going to be my 2 options. I'm going to do whatever is easiest. Okay? Atoms are lazy, they want to do whatever is easiest. So let's look at group 1 here. I have 1 valence electron. So my options are going to be kick 1 out or find 7 more. Kicking 1 out is going to be a lot easier. When I lose an electron, I become positive. I'm a cation. So I lost it, I'm positive, and I got rid of 1 of them. So my charge there is going to be a +1. Let's check out group 2. Kick 2 out or find 6 more. What's going to be easier? Kicking 2 out or finding 6 more? Kicking 2 out, yeah. So I kick 2 out. Losing electrons makes me positive. I'm a cation. So my charge for group 2 is +2. Now let's check in on group 13 here. I can kick 3 out or find 5 more. Kicking 3 out is going to be easier. So I'm going to kick 3 out. When I kick them out, I become positive. So my charge there is a +3. Now when we get to 14, my options are kick 4 out or find 4 more. That's the same. So group 14 is a little tricky. For things like carbon, we're going to do a lot of sharing. Okay? Think about biology, things like that. Carbon-based life forms, That's a pretty key part of what we'll be looking at. Those usually are covalently bonded. And then we will be looking at stuff like tin and lead. They don't have just one standard ion formation. They have more than one charge. So group 14 is kind of a special circumstance. So when we're talking about standard charge and standard ion formation, we actually skip group 14. And we'll talk about when we name ionics, what we do there instead. And then when we talk about covalent bonding, we'll talk about how that sharing occurs. So for this second part right down here, we're actually skipping group 14. So let's bounce to group 15. I can get rid of 5 or find 3 more. Okay, so finding 3 more is going to be easier. If I take on electrons, I gain negativity, so it's going to be a -3 charge. Group 16, I can get rid of 6 or find 2 more. Finding 2 more. So I've gained electrons, so I'm negative, and I gained 2 of them, so I have a -2 charge. Group 17, I can get rid of 7 or find 1 more. Yeah, finding 1 more is way easier. So I took up 1 electron. Electrons are negative, so I have a -1 charge. Now group 18, it wants 8. It's perfect, in its eyes at least. So it doesn't want to do anything. It's going to be neutral. It does not want to bond. It's part of why we didn't discover noble gases until later on, because a lot of initial research and development on the periodic table had to do with reactivity. So a trend here is +1, +2, +3 skip, -3, -2, -1 neutral. So this is kind of the middle ground where the numbers and charges flip. Now let's say if I wanted you to write an ion for that. So let's put together what we looked at the beginning and what we just did to actually write our ions. So we're talking about standard ion formation here. So period 3, group 1, we already said that was sodium. And we said that it had a +1 charge. Remember, when we write ions, our charge is up and to the right. It's a superscript, Superman flies. So a +1 there. Group 2, period 3 was magnesium. And it had a +2 charge. Group 13, period 3 was aluminum. And it had a +3 charge. Again, we're skipping group 14 because it does not have that standard ion formation, that regular charge, and we'll talk more about that when we talk about non-patterned metals and covalent bonding. So when I get to group 15, I have phosphorus, -3. 16, I have sulfur with a -2. 17, I have chlorine with a -1. And because our noble gases do not like to form ions, we just need to write them as a neutral atom. So that's kind of a look at our first major link that we're looking at between the periodic table and the ions that we talked about earlier.